All right, guys. We're going to continue our absolutely riveting discussion of inverse trigonometric functions. Yesterday we talked about sine and inverse sine, and we had to restrict that domain when we made the inverse, right? Do you remember why we had to do that? Yeah, it's not going to be a function. If we turn it on its side, and I can make the same kind of example here out of cosine. If I take this guy and turn it on its side, it does this, right? Not a function. I realize my picture is far from exact, but you get the idea. What is the domain of cosine? All real numbers. What is the range of cosine? -1 to +1. Since it's not a function when I take it and I turn it on its side, when I make it into the inverse, what am I going to have to do to my original function so that my inverse can be a function? I have to restrict the domain again. When we talked about sine, does anybody remember from yesterday where we restricted the domain for sine? -π/2 to π/2. Because if I had it from -π/2 to π/2, none of those y values repeated themselves. If I look at that same interval here, are any of the y values in this space the same? Then I can't use that as my restriction here. I like to stick around the origin if I can. So I'm going to start at 0. How far over can I go until the y values start to repeat themselves? Over to pi. So we are going to restrict this domain from 0 to pi. All right, so I'm going to put up my picture here. This is what the inverse of cosine looks like when I have restricted that domain. So my domain for the inverse is what? Look at this inverse graph down here. From -1 to 1. And the range is going to be what? 0 to pi. From 0 to pi. Do you guys understand why we have to restrict that domain? Yes? No? Okay. Just making sure that we're understanding why. All right, so we've talked about sine yesterday. We just talked about cosine. Who else do you think we need to talk about? Tangent. Let me pop up my tangent graph. That's what tangent looks like. What is the domain of tangent? All real numbers. Yes. X cannot be equal to π/2 plus pi n. Because π/2 we have an asymptote, and then you have to go halfway around the circle to get to the next asymptote. And every time you make a half rotation around the circle, you run into another asymptote because tangent is undefined there. What is the range for tangent? -∞ to +∞. All real numbers. Because that's what -∞ to +∞ means. So far, so good? All right, so I want to imagine if I were to just take tangent as it is and have the inverse, what would it look like? Yeah, it's gonna reflect it over the line y equals x. So it switches the x and y coordinates. Instead of being these squiggles that go up and down, what's it gonna do? Side to side. So we're gonna have a tangent squiggle here. It's gonna have an asymptote. And it would have a tangent squiggle here. Would it ever stop? No. Is that a function? No. Is that a function? Yes. That is a function. This is not, because a vertical line would cut through multiple of those. But that's a function. So what am I going to need to do here also? I need to restrict the domain. Why don't we focus just on this guy? We'll restrict the domain to just that one where the x and y axis cross. So we're going to get rid of this. We're going to get rid of this. So what's that window that I'm looking in now for my domain? Negative pi over 2 to pi over 2. Just like when we were talking about sine, we restricted it to that same window. Yeah, I had my typo there. You're not even paying attention. So what is my domain for the inverse of tangent? All real numbers. What is my range for the inverse of tangent? Negative pi over 2 to pi over 2. Now for sine and cosine, after we restricted the domain, we used brackets. Does this get brackets or does this get parentheses? Why? Because we've got those asymptotes. It's never actually going to touch negative pi over 2. It's never actually going to touch pi over 2 because those are undefined values for tangent. You guys okay with this so far? All right. I am going to put up a screen that has a summary of what we've just talked about with the sine, the cosine, and the tangent. If you want to snap a picture of it, you're welcome to, but it's just a summary page of everything we've talked about. You do not have to copy all this down. So I've got all of it just up on one screen. This is why I broke it into pieces. So I was not about to put this up as like, here's all the stuff you need to know about inverses. Let's go. These pictures down at the bottom are showing the original function with the restricted domain and the inverse on the same graph. For inverse sine, what part of the unit circle are we going to be paying attention to? For inverse sine, first quadrant and the fourth quadrant. For inverse tangent, we're paying attention to what? First and fourth again. What about for cosine? First and second. Cosine is odd man out. We're looking at the top half of the circle for cosine, but we're only looking at the right-hand side for sine and tangent. So far, so good? All right. If you wanted a picture of this, I hope you got it. Did you want to grab one?
No, I'm ready.
Okay, got it. All right. So the question of where am I looking? For arc sine, for inverse sine, you said we're looking where? I'm sorry, one more time, Alex. 1 and 4. So we're going to go from right here to right down here. Here's my arc sine. Or sine using my inverse notation. Same thing, we talked about that yesterday, right? What's this angle up here? 90 degrees, or in radians it would be pi over 2. Now I want you to think about how we talked about the arc sine. We said it went from what to pi over 2? From negative pi over 2 to pi over 2. So instead of referring to these angles over here as 3 pi over 2 and 7 pi over 4 and 11 pi over 6, we are looking negative angles this direction. Keep that in mind as we're working on these. Negative angles if we're in the fourth quadrant. Nothing bigger than pi for anything. For sine and tangent, nothing over pi over 2. Where are we looking on this unit circle if we're talking about cosine? 1 and 2. So cosine, we're looking from here to here. So here's my arc cos, or cosine with my inverse notation. We're going from 0 to what? 0 to pi. And last but not least, arctan. Same as with sine. So arctan is like this. Or I can write it as tangent with my inverse notation. I'm going to give that function a new name. It's now tanverse. All right. Let's practice with these guys a little bit. We're going to do some evaluate without a calculator questions. If you want to grab a picture, snap a picture of this guy. And I do post all these on Canvas for you guys, so if I ever go too fast and you don't grab a picture of it, you can always go grab a screenshot of it later. Arc cos. What part of the unit circle am I looking at for arc cos? 1 and 2, quadrants 1 and 2, so top half. So I draw myself a little picture so that I know where I'm looking. And if you see arc cos or inverse cosine, that's saying cosine of what angle gives me radical 2 over 2. That's the question I'm answering here. So what is the angle that has cosine of negative radical 2 over 2? 3 pi over 4. Is that in the top half of the circle?
Yeah.
Then we're good. So this is equal to 3 pi over 4. Arctan. What part of the unit circle am I looking at for arctan? 1 and 4, right side. So like this. So tangent of what is equal to radical 3. Tangent is sine over cosine, right? So if tangent is sine over cosine, then I know this would need to be radical 3 over 2 and then 1/2, right? Because those 2's are going to cancel out. Where's that happening at? What quadrant? Let's start there. First quadrant. So in the first quadrant where sine is radical 3 over 2 and cosine is 1/2. Pi over 3. It's going to be up higher. Yep, so pi over 3. Are you guys okay with how we're doing this so far? Do you understand what I'm after when we're asking about arc cos and arc tan? Okay. Arc sine. What part of the unit circle am I looking at? 1 and 2. I know it might seem silly, but I draw my little like arcs here so that I know where I'm looking. It reminds me I'm not looking at the whole circle here. Where is this? Zero. Absolutely. Because anytime I'm after inverse sine, inverse cosine, inverse tangent, I want to know what is the angle. So this is saying sine of what angle gives me a value of 0. And that happens at 0 radians. So far, so good? All right. Tangent. Where am I looking? 1 and 4. So tangent of what is equal to -1?
Is it 7 pi?
Yes, except negative pi over 4. Because remember, when we're talking about the right-hand side, we're going from negative pi over 2 to pi over 2. So I know that this down here, 7 pi over 4, yes, but that's not in the range that I'm looking. So I have to write it as a negative angle. So that would be negative pi over 4. Because when we measure it this way, we have our negative angles. Tangent and sine are going to behave like that. So here's one of the things that I do for tangent and sine. I think about what would it be if it was positive? Where would that be in the first quadrant? And then I just slap a negative in front of my answer. So think about where it would be in the first quadrant. If it's a negative, just put a negative in front of your angle. I want you guys to do 5 and 6 on your own. And then we'll check back in about, I'll give you about a minute for each one. So in about 2 minutes. Number 5. What is this? Pi. This one is pi. Because it's saying cosine of what angle has an output or a value of -1. Cosine is -1 over at pi. What about number 6? -pi/4. Because if it was positive, that would be pi/4. So if it's negative, it's going to be -pi/4. Yes, ma'am? Yes. So we said domain for inverse sine. Do you remember what we said our domain for inverse sine was? -1 to 1. And what did we say the range for inverse sine was? It's not the same thing. This is what we had to restrict the domain of sine to. Does anybody have it written down from yesterday? What did we say the range on inverse sine was? From -pi/2 to pi/2. So all of our answers, all of our output has to be in here. So 7pi/4, that's too big. That's outside of that range. Does that help answer your question? Yes, that's why we had to do that. That's a fantastic question, and I'm glad you asked me to clarify that. All right. I'm going to put up 3 more problems like these. I want you guys to do all 3 of them on your own. I'm only going to give about 1.5 to 2 minutes for these 3. Number 7. I know I'm looking in quads 1 and 4, This is one of those ones that's kind of tricky. Negative pi over 6. Remember, if it's in quad 4, it's just going to be negative of whatever it would be in quad 1 because of that domain restriction for the original function, range restriction on our inverse. What about number 8? Negative pi over 6 again. All right. Number 9. 2 pi over 3. Because here we're looking top half. So for my cosines, I'm not going to have negative angles. For sine and tangent, if I have a negative value, then I'm going to have a negative angle. Cosine, top half. I don't have negative angles for cosine. So far, so good? Please let me know if we're confused anywhere, because I want to make sure I'm not losing anybody at the beginning of this. Okay. For these next two, you're going to need a calculator. I want you to evaluate these with a calculator. If you need to borrow one from me, you are more than welcome to come up here and grab. Huh? Yes. Good question. Yes, you should be in radian mode. If you don't know how to put the calculators into radian mode, please raise your hand and ask. I am more than happy to show you how to do that. All right. So for our arc cos of 0.85, tell me what you're going to type into the calculator if you haven't already. Because that button is not on the calculator. Yep. Inverse cosine of 0.85. And that gives you what in radians? How much? 0.555. 0.5548 something something something. If you don't know how to get that on your calculator, please raise your hand. I want to make sure everybody knows how to use the calculator to do our inverse functions as well. Because if it's stuff from the unit circle, we can get exact values. But if it's not from the unit circle, we have to be able to put it into the calculator. Radian mode. Do you have it in degree mode? Because I actually want to write that down. So let's write it down in degrees. Pedro Hun.
Oh, wait. I took it off. It wasn't in degrees. It was 31.7.
You said 31.78?
Yeah. Well, 79.
All right. I'm fine with writing it down as 78. All right. To put it into radian mode on this kind of a calculator, you're going to push mode, and then you just arrow over to radians.
So we have to do 4 spaces for radians, or you just did 4?
No, I just did 4 rather than write 555.
Yeah.
Because I just want to make sure that everybody's understanding, like,
Okay.
that we have enough for comparison purposes. Yeah, 3 decimal places is always sufficient for me.
Okay.
Yep. All right, so arc sine. What are we putting in the calculator? Inverse sine 3.14. Why? Yeah. So we said the domain for inverse sine was what again? That's my range. No, that's okay. that was our domain restriction on the original function. So my brain often goes to that also. The range was negative pi over 2 to pi over 2. Negative 1 to 1. So why is this coming back as a domain error? Yeah. 3.14 is not in the domain of inverse sine. It's too big. So this is undefined or not defined. No solutions, if you will. I do not care whether you write not defined or undefined. What does the prefix un mean? Not. So if you write not defined, it's exactly the same thing as undefined. All right. Next screen I'm going to put up. Take a screenshot of it first. Take a picture of it first, and then we'll talk about these pieces. It's a lot of information all on the screen at the same time. We're going to talk about what these pieces mean. So grab your phones and snap a picture. All right. So here's what all of this means. If I add 5 to something and then I subtract 5 from it, what happens? Yeah. Those two cancel out, right? Because addition and subtraction are inverses, right? What about if I had 3x divided by 3? What happens? It's just x. Because multiplication and division are inverses. All this text up here is just basically saying the same thing. Sine and arcsine are inverses of each other. So they're going to cancel each other out. It doesn't matter whether I do the arcsine first and then the sine, or the sine first and then the arcsine. These cancel because they're inverses. There is one tiny thing that we do have to pay attention to, though. We have to make sure that if they're giving us the arcsine of a value, that value is in between -1 and +1, like we just saw on that arc cosine example, how it was a domain error because it was not in this interval of -1 to +1. So if we have the inverse sine or arcsine, inverse cosine, or arc cosine, that value has to be in between -1 and +1. For our angle, so if they're giving me sine of a value, that number has to be inside that domain restriction, in between -pi/2 and pi/2, or else I can't do it, because we restricted the domain of our original function. Same kind of thing down here with cosine and arc cosine. Those two things are going to cancel each other out because they're inverses. If they give me arc cosine, still has to be in between -1 and +1. What about if they give me cosine inside these parentheses? That angle has to be in between what and what? Where are we looking for cosine? Think about what we said our domain restriction was for cosine. We're only looking at what part of the circle? Top half, 1 and 2. So it has to be in between 0 and pi. Any angles that they give me for cosine have to be in between 0 and pi. Otherwise, it's outside of that restriction and I can't do it. Tangent, same story. What happens to tan and arctan? Cancel, because they are inverses. Are there any restrictions on what kind of value I could put in with arctan? This just needs to be what? Arctan, I just need a real number. Because we said that the domain of arctan was all real numbers. Remember, it's tangent on its side, so it goes like this. All real numbers for arctan. But if they give me tangent of an angle, are there restrictions on that? Tangent of an angle has to be between what and what? Negative pi over 2 and pi over 2. Yes. All right, I want to practice a couple examples with these, and then we'll shut it down for today, and we'll keep working on it tomorrow, okay? Let me write this down. Okay, first 3 examples. Did we have any restrictions on arctan? Let me go back and look. Down at the bottom. That's like this one right here. Are there any restrictions for arctan? Nope. That domain is all real numbers. So is there a problem with this 25 here? No. What's going to happen to tan and arctan here? Cancel. So this all simplifies to what? 25. Do we have restrictions on arc sine? Has to be in between what and what? -1 and +1 for arc sine. Is this value in between -1 and +1? Yes. -1 is less than or equal to -0.2, less than or equal to 1. It meets those restrictions. So what happens to sine and arc sine? So this whole thing simplifies to -0.2. Do we have any restrictions on sine? Sine has to be in between what and what? -pi over 2 and pi over 2. Is 3 pi over 8 in that window? Yes, it's bigger than -pi over 2, and it's smaller than 3 pi over 2. Or sorry, smaller than pi over 2. I was looking at the 3 there. So sine and arc sine cancel out. The whole thing simplifies to 3 pi over 8. As long as the value that's inside the parentheses meets those restrictions, my inverse functions are going to cancel each other out. I want to look at just 3 more quick ones like this. What kind of restrictions do we have on cosine? Has to be in between what and what? For cosine? Cosine has to be between 0 and pi. Is this angle in this interval? Yeah. So inverse cosine and cosine cancel, and this is 3 pi over 4. What's tangent of negative pi over 2? Undefined. So are the inverse tangent and tangent going to cancel? No. This whole thing is just not defined. Last one. Inverse cosine has to be in between what values? -1 and 1. Is this value right here in that window? Yes or no? Is square root of 3 bigger or smaller than 2? Smaller. So would this whole fraction be bigger or smaller than -1? Smaller. Closer to 0. Closer to 0. There we go. So my cosines are going to cancel, and this is just radical 3 over 2. Yes. Thank you. It is negative. All right. We will pick up here tomorrow. We'll keep moving forward with 7-6. I have posted the 7-6 homework, although obviously we have not gotten to everything yet. Most of the 7-6 homework is multiple choice. Feel free to get in there and start working through it.